Alright, hey guys, this is 13.2, algebraic techniques for finding a limit. So we saw this in the very last section, 13.1. We saw the introduction to algebraic techniques. So we're going to go a little bit more in depth with that. So the limit of a constant and the limit of x. So a constant, again, just a horizontal line. Well, the limit of that is always going to be the constant. It's always going to be that value. The limit of x, well, it's going to be whatever you're taking the limit of. So if it's c, that limit's going to be c, okay? Because wherever you're at on the x-axis is going to be wherever you're at on the y-axis. So we're going to start with those basic ones, and then we'll kind of move our way up. So the limit as x approaches 1 of 2 is just going to be 2. The limit as x approaches 4 of x is going to be 4. Okay. The limit as x approaches 0 of -4, that's a constant. Okay, so it's going to be whatever's in there. And then the limit as x approaches -pi of x is going to be -pi. Okay, so remembering those simple rules will help you out a lot to save you a little bit of time. Alright, limit of a sum or difference. So we're going to kind of go through the long way of this and then hopefully notice a little bit of some patterns here. Oops, just dropped my pen. Alright, so if we break down a limit of a sum or difference, you're just going to end up adding the limits or subtracting the limits, okay? So, limit as x approaches 3 of x minus 2. So we can break this down into limit as x approaches 3 of x minus limit as x approaches 3 of 2. Alright, limit as x approaches 3 of x, well, that's going to be 3. And then limit as x approaches 3 of 2, that's going to be 2, because that's a constant. 3 minus 2 is 1. Okay, so that's using the same techniques that we just did above. Well, let's see if we can recognize any simpler way to do this, because that seems like a lot of effort. Okay, so I introduced at the very end, like I said of last time, that we can recognize that x approaches 3, we can plug this in. So limit as x approaches 3, and then plug that in, that's going to be 1, okay? So we're able to just plug that in, but that comes from what we did above with the constants and the x, okay? So it works the same with multiplication, that the limit if you multiply two limits, that it's going to break down into the two limits multiplied. But again, we recognize that we don't really have to do all that work. We can just plug it in. So the limit as x approaches -1 of 3 times -1 is going to be -3. Okay, same thing here. So 2 times 5 minus 3 is going to be 7. We're just plugging in whatever we're approaching. -3, -1 squared. Okay, watch our algebra here. -1 squared is +1 times -3 is -3. Okay. Alright, last one down here is 2 times 5 to the third. 5 to the third is 125 times 2 is 250. Alright, limit of a polynomial. So as x approaches 2 of this big long polynomial, but again, we know that as x approaches 2, that everywhere I see an x, I'm going to put a 2. Okay, so that it's substitution there. So it's just p of c as x approaches c. So 2 times 2 to the 4th minus 3 times 2 to the 3rd plus 2 squared plus 5 times 2 minus 4. That will end up being 18. Okay. So next one we have quotients and we have powers or roots. So these work very similarly. Okay, the one thing that gets a little bit tricky is the powers and the roots. The quotients, very similar, but we do notice that this g of x on the bottom can't equal 0 because we can't divide by 0. Okay, so let's start with this one. Again, very similar. If I have x approaches 0, then I'm going to substitute in 0. Okay, so 4 minus 3 times 0 is 4. So 4 to the 6th. And if I type that in my calculator, 4 to the 6th, I get 4,096. Okay. Alright, same thing here. This time x is approaching negative 2. So square root of 2, negative 2 squared plus 5. So negative 2 squared is 4. 4 times 2 is 8. 8 plus 5 is 13. So square root of 13. Alright, next one, x is approaching 1. So 3 times 1 to the 3rd minus 4 times 1 plus 9. So that's 3 minus 4 is negative 1 plus 9 is 8. So 8 to the 2/3. Okay, so 8 to the 2/3 is equal to 4. Alright, next one. So x approaches 1 here. Again, we can just substitute in 1. Okay, so negative 4, 1 to the 3rd plus 1 squared minus 2 times 1 plus 4 over 2 times 1 minus 1. So negative 4 plus 1 is negative 3, minus 2 is negative 5, plus 4 is negative 1 over 1, so that would be negative 1. So a lot of these are just going to be, so far, are just about plugging in the value. Okay, so now we're going to get to ones where it's a little bit more complicated. Okay, not much, but you're just going to have to use some factoring techniques. So here we have the limit as x approaches 3. So let's try to plug in 3. 3 squared minus 3 minus 6 over 3 squared minus 9. Alright, well automatically I notice a problem because 3 squared minus 9 is 0. Okay, so automatically I have an issue, and actually I end up getting 9 minus 3, which is 6 minus 6, I get 0 over 0, which you'll end up learning later that's an issue. Okay, you can't have 0 over 0. Okay, so I'm going to end up erasing all that. If you wrote it on your paper, that's fine, just cross it out, because a lot of times you want to check that first, right? So what I'm going to do is then I'm going to factor it, okay, just like we ended up doing before. Okay, so always check that first, is can you plug it in? And if you can, that works, move on, okay? But I'm going to factor this. So I get x minus 3, x plus 2, and then the bottom's going to factor into x plus 3 and x minus 3. Okay, now I can cross out my x minus 3, and I get the limit as x approaches 3 of x plus 2 over x plus 3. So I notice that there is a hole at x equals 3. So I'm going to have something, obviously this is not my graph, but something that looks like this, where I have a graph, there's a hole, and then it keeps going. But I know I can still find the limit of that, okay? So I can still find the limit. This goes back to what we did at the very first page, I believe it was, where you still can find the limit right here, even if there's a hole, okay? So now let's try to plug it in. I should be able to find something. 3 plus 2 over 3 plus 3, so 5 over 6, and that's going to be your limit. Okay, so as x approaches 3, then I can go back and plug it in. And that's actually, if you learned where back in rationals, if you remember back in rationals, that's like where the hole would exist. Okay, so the hole would be at 3, 5, 6. Okay, if you remember back from your rationals unit. Okay, so that would be the value of the limit. So as x approaches 3 from the left and from the right, it would equal 5, 6. All right, next one. So we're going to try again, plugging in 0. Now, hint, none of these are going to work, but it's okay. So 5 times 0 minus sine of 0 over 0. Well, I automatically know I have a problem because I have 0 on the bottom. Now, sine of 0, if you go over to your unit circle, 1, 0, I have an issue there. And 0 minus 0 is 0. Okay, so that's not going to work. So let's erase that. Alright, now this one I can't really factor, right, because I have a sine of x, but I can break it up into something that I know. Okay, so I'm going to break this up. So limit as x approaches 0 of 5x over x minus limit as x approaches 0 of sine of x over x. Okay, this guy right here should look familiar from the I want to say it was the very first page, if not the second page. Okay, all right, well, let's start with this one first. 5x over x is just the limit as x approaches 0 of 5, so that's a constant. That's 5. Okay, sine of x over x. Now, if you don't remember it, well, you can type that on your calculator, look at the table, anything like that. Okay, so looking at the table, we end up figuring out that that's 1. So minus limit as x approaches 0 of 1. So 5 minus 1 is 4. Okay, so that one you will have to either go back and remember that sine of x over x, the limit as x approaches 0 is 1, or if you don't remember that, look back in your table on your calculator. Okay, this one we already did in the previous video. Just remember, I'm going to factor. I'm not going to spend the time factoring since we already did that, but it ends up factoring into x squared plus 4x minus 2 on the top, x to the third plus 1, and x minus 2 on the bottom. Okay, and so then it factors, then you cross these out, and you get x squared plus 4 over x to the third plus 1. When you plug that in, you get 8/9. Remember, you're plugging in 2 because x approaches 2. Okay, so that is limits algebraically. So remember, your first goal or your first option is you can plug it in, okay, and to see if that works. But if you get an issue like 0 over 0, then you're going to have to try some other techniques to see if there's some other options there. Okay, so that is limits algebraically.